the timer being up, but I don't see the video feed. That's weird. Just a second. Let's see. Let's see if the video feed is fine or not. Okay, I think the video feed is also looking okay. So welcome to the day 3 of vibe coding a message queue. I had made a lot of progress since yesterday. So essentially what I did was our message queue was unnamed yesterday. So now we have given it a name. It's called Quick Pulse now. So it's a blazing fast in-memory message queue. Essentially what I did was I did a couple of things. One is I created a doc file so that anybody can run this on their system. I added a couple of demo files which anyone can use and test the Quick Pulse server. So our message queue is called Quick Pulse, and everything is in-memory, ephemeral, and so essentially what you can do is you can build your Docker image and you can go to make file. If you don't want to build the Docker image, you can just directly run these commands. And if you're not sure, you can just do make help and it'll tell you what each command is supposed to do and where your Prometheus metrics will be available. So from yesterday, I think where we left off the stream till today, there's not a lot of changes. Essentially what I've done is if I go to main.go, I've added one more mode, which is bidirectional streaming via gRPC itself. So apart from sockets and gRPC Unary, there is one more mode, which is the RPC stream mode. And essentially what it does is, I'll show you what it does because the throughputs that I've been getting is amazing. So do you see this beautiful peak? So the numbers that you see here are slightly crazy. So it's like 824 messages per second, but I think the Prometheus dashboard is like glitching for some reason. The actual throughput was about 400,000 messages per second, which is absolutely crazy if you like ask me. For example, if I just ask, sorry. Okay. So I'm just going to tell GPT. So I'll just take a screenshot and tell it that, hey, this is my message queue system. Okay, nice. So yeah, so error rates are there, but they are like, this is not zero, but it's essentially very less. So not alarming. Anyways, it's ephemeral, and what I was thinking was it can be used. So Quick Pulse, this thing that we have built, most likely can be used for like analytics use cases where the payload size is not that high, and you just want to like fire and forget and kind of take care of all the data later. It's just like relentless publishing and consuming at the other end. So yeah, like 400,000 messages per second is like crazy throughput, like if you ask me. So comparing to other messages, okay. So let me share this thing. So these are my system specs. Where is it? Here. So let me just share these details also, and to see how it actually like, you know, competes or stands up against other message queue. Yeah, so I'm not actually targeting like on distributed compute front. Wanted to keep things as simple as they are in the beginning, and then of course there's like not even a topic and everything. So okay. Yeah, so comparative performance analysis, this is what I want to see. Your results indicate messaging system is already quite optimized. Given the performance on an M1 Pro, scaling to more robust server grade hardware might allow you to push the envelope even further. I'm pretty sure I can push it even further with the architecture that we have. Sorry. So docs, where is my UML diagram? Yeah. So if you see, right, I'm pretty sure there's like a lot of places we can still optimize this. But of course, that's like uh, by a lot of places. I mean, so essentially everything is like actually just binary and kind of already gracefully handled. So if you see, right, the core of our queue essentially is just what, 87 lines, and it works all right. I've not even tested the consumer bit. So essentially, now that we have like kind of optimized for the producer aspects of our message queue, we now probably would want to see how the consumer works. Um, so there's that, of course, but you know, that I'll probably will have to figure out sometime later. Okay, let's go back to what GPT has to say. While throughput is significant performance indicator for the measurements, especially, I think I am capturing latency. Let me see. Okay, I think I stopped the servers. I'll just do make run grpc stream. This will spawn up the server. It's like this beautiful ASCII art also. And yeah, I'm kind of proud of this. Didn't spend much time on this, but yeah, this looks beautiful. Okay, now our Prometheus metrics are coming. I want to see the latency. Where do I see latency? Yeah. So before I do this, let me just do this, and let me just do this. Why? Okay, let me just fire the perf again. Okay, for some reason I'm not getting NQ latency. That is weird. It should not. Okay, I have the numbers here, but it's not showing up in the graph. Okay, that's weird. NQ latency, seconds bucket, seconds sum, seconds count. What is this? Okay, so latency I need to see. Seconds count. What? Latency seconds. Okay, let me see my Prometheus file. Metrics. MQ metrics, Prometheus metrics.co, and unnamed NQ throughput, unnamed NQ. Okay, so this is still called unnamed MQ. I need to change it to Quick Pulse. So by the way, if you guys want to kind of contribute to this, Quick Pulse have not added yet a license to this kind of this repo itself. Planning to still keep it open sourced and like for people to kind of contribute and see if anything can be made better. So yeah, just like if you want to contribute, if you see all these things like this improper naming of, let's say, Prometheus metric or something even on the architectural front, feel free to raise issues and like, you know, contribute. I haven't added contribution guidelines, which I'll do probably today evening or tomorrow. But yeah, essentially that's the thought. Okay, so the metric is called unnamed in MQ and Q latency seconds, but we are not getting that data. Why is that the case? Yeah, so okay, let me just refresh this status on the target health. Everything is running. Okay, let me see the graph. Oh, let me see, explain. No, I can't do that. Count. Okay. Okay, I'll figure this out, but most likely what's happening is these are like submetrics, which of course is not there. Anyways, take it. So this is fine. NQ throughput, NQ total. So we haven't even tested the DQ aspects of our message queue system. So that also is something which you guys can contribute to if you want. But yeah, okay. So this is essentially the North Star metric for our message queue. Okay. Mac OS is capable if your primary deployment targets include Linux-based servers running similar benchmarks on those systems. Okay, that's a good idea. Okay, base is the above. So what I'm planning to do is, so this live stream essentially was just to kind of, get you folks up to the speed what I've been working on, and like we're in like a decent enough place. What you, essentially everyone can kind of try QuickPulse on their local machine. They just have to build so essentially the way to do it is you can just build the Docker image. You can run it in whichever mode you like, and once that is there, you can then refer to these commands. Yeah, so you essentially then, so once your Docker setup is complete, you just have to run your perf client, and then you can run any kind of mode. You have Unary, streaming, and sockets mode. You can run it and see how it works on your system. So I tried it on the older machine, and the throughput that I was getting in the Unary mode was about 50,000-ish. But on this machine, if I just stop it and I do make run just gRPC, and then I just do the perf for gRPC, I'll get about 135k. So it also depends on your system, but the point is you folks try it and see. Yeah, it's 115-ish messages per second. Whereas if I just do make run gRPC stream and I do go run gRPC stream, now if you see the throughput is, I think it's going to be like 400,000-ish. I also want to try one thing, which is perf client. No, not this, cmd/main. Yeah. So here, if you see, right, this is 5 seconds. What if I just like change it down to 3 seconds or something? I can start this again, and what happened? Test duration in seconds. That's the only change I think I did. Okay, that's very weird. What all did I change? Okay, let me see if I can run it in simple gRPC mode. Okay, that works. Okay, this also works somehow. So all these intermittent things are also something that we can really take a look at and like figure out what's to be done. So now it's working. I don't know why that was the case. Okay, so now we have 4 seconds for 2 million messages, and the throughput should be around. See, it's like it's completely client dependent. If I can do this thing, right, if I'll just do 2 seconds, I'm pretty sure I can get 1 million messages a second. I think it's like probably the ports are not getting cleared up properly. That's the only thing that I can think of. So if I run it now, it's still not working. Okay, I'll do one thing. I'll just do 1 second. What about 3 seconds? Okay, if I just do make run gRPC, it works. But if I do make run gRPC stream, then also it works. I think it's like probably some issue related to port caching or something. So now if I just do probably 2 seconds, and if I do this and then do this, I can simply run the perf client in gRPC stream mode. Of course, here there is issues because we are not giving enough time, and of course the context deadline is getting messed up. So okay, so I can do probably 3 seconds. So 4 seconds work. We were able to reach a throughput of 500,000 messages. So if I can just remove this and I'll increase the time and do this. So if you see like somewhere around that 500,000 messages. Oh, okay, so this is like 700,000 messages per second. Okay, and I can do gRPC stream. Okay, so 3 seconds also maybe works. Okay, 600,000 messages per second. That's like beating most industry standards. Okay, so the actual number shows like 900,000 messages, or at least the peak. So this is, so just understand this is like the peak throughput that you see in the Prometheus dashboard, and the throughput that you see on the console, it's like the average throughput. So average throughput was around 664,000 messages per second, and the peak throughput that we reached was about 890. So, I mean, this is like pretty interesting because if I can just say peak throughput reached was 1 million. Hmm. Oh, okay. Let's see. It's a remarkable performance figure, especially when you consider most high performance most impressive number only under tightly controlled conditions. So it's like, of course, our message queue quick pulse is, of course, very opinionated. It's using in memory for storage. There is no persistence. There is a ring buffer queue. We primarily only care about bytes, slices of bytes for storing our data. So all of that is still there, but all things considered, I think we are okay. Okay, Kafka has been shown to process anywhere from 1 million to 7 million messages per second, unless diskless configurations and optimized hardware benchmark reports number that can match or exceed your 1 million in high throughput scenarios. That's all right. RabbitMQ is extremely versatile, but typically does not reach peak throughput as Kafka, show maximum throughputs in lower hundreds of thousands. So we have already beat RabbitMQ. What about NATs? Simplicity and speed in mind, often adopted by systems that require very low latency. Along with this, and tends to be comparable to or even exceed the numbers you have seen. That's okay. That's fine. Um, okay. In-memory speed is paramount and persistence to be secondary. All the many production deployments rely on additional layer. I don't care. So, QuickFull's philosophy is we don't care about durability and reliability. It's fire and forget, very high throughput, and so whatever use cases kind of resonate with this kind of philosophy, it works the best for them, or at least in theory it works the best for them. Reaching around 1 million messages per second in a peak producer flow indicates that your message queue is competitive with industry leaders like Kafka and NATS under optimal condition. This suggests that the low level architectural decision using gRPC streams effectively, minimizing overhead and efficient concurrent management is sound. Actually, the thing is, we didn't do anything here. If you see, I was thinking about this also, because if you see our queue, right? So wherever this is called, for example, let me see if I can figure out where enqueue is called. Okay, so it's primarily only called in instrumented queue and then in gRPC server when the produce method is called. Now the problem here is we are of course using atomic counters and everything for essentially like thread safe operations. That's all right, but the problem is we have not kind of done anything in terms of concurrency. It's very simple. So now that I think, when a producer calls this, or when the gRPC unitary server structs or classes produce method is called, I was thinking, what if I can just simply do this in like a separate go routine and all that? But then I thought, what if there is multiplexing kind of overhead? So I was not sure. So that's also something that we kind of need to try and see if the throughput via that, if we can tune that number of concurrency, how does the throughput kind of stand against those numbers? So that's also there. That's also one kind of consideration that we didn't do. Okay. So while 1 million messages per second is an excellent throughput figure, production systems must also consider aspects like latency, fault tolerance, and consistency, ensuring that your consumer processes can handle a high influx of messages and that system remain stable under sustained load is equally important. That's okay. Longer duration test, multi-node deployment, simulations that factor in network. Yeah, this is so persistent overhead we will never have, because I will never want to kind of do this durability and reliability thing. But simulations in different kind of networking environment is something that I would want to do. So yeah, that's there, of course. Okay, cool. But yeah, the general point of the stream was to kind of tell you that okay, so I'll just do one thing. I'll update this in the description of this live stream. Quick Pulse MQ GitHub repository link. Let me just copy this. I'm just updating the description, so anyone who wants to kind of contribute to it can contribute to it, and save. Okay. So this is now, the repo link is now in the description. We have like made significant progress in just 2 days. We have our own message system with like peak throughput at around I don't know, 900,000 messages per second. This is like crazy. Okay, so yeah, this is pretty much all about this stream. Wanted to kind of give you an update on this, and probably I'll make like a release video for Quick Pulse. Super proud of this kind of stuff. Always wanted to do it, just that I was not getting enough time. So yeah, our blazing fast in-memory message queue, opinionated message queue is semi-live. So yeah, cool. Thank you for watching. I'll be ending the stream. See you guys probably sometime tomorrow or next weekend. Cool. Bye-bye.